see the slides already.
Yeah. Oh, sorry, I was muted. Perfect. Just quickly checking, Uwe. It seems according to schedule, we are almost 4-minute delayed, right? Or are we starting?
You have your full 15 minutes.
Perfect. Okay. Perfect. Then I can get started. Hello, everyone. My name is Dhruvin Patel. I'm from Ericsson Research, placed here in Aachen, Germany. I am project manager of Deterministic6G, and today I would like to give you a brief introduction of the project within the next 15 minutes. So yeah, given the time period, I have structured the presentation around this following points. Instead of going directly into project details, I would start with a bit of motivation, giving you a higher overview, why deterministic communication is needed, further going into deep details about the vision of the project, the objective, the consortium, and concluding with the summary. If we get more time, I can dive deep into further technical details about the project. So without wasting any time, let's get started. So today we see digitization that is transforming societies and industries. And while this digitization journey has already started, it is expected to dramatically accelerate in 2030 timeframe, as more and more technical enablers such as immersive interaction, AI, edge computing matures and sparks innovation. So this development are expected to converge toward what we envision a cyber-physical continuum between a connected physical world of senses, actions, experience, and its programmable digital representation. So a cyber-physical continuum spanning across several application areas, covering control applications, wearable robotics, or immersive interaction, is only possible when you have underlying end-to-end deterministic communication infrastructure. So this end-to-end deterministic communication infrastructure is going to play an important role as a glue that bridges this physical world and the digital world for a wide range of applications. And these applications requires deterministic behavior from a sensor to the cyber-physical representation in the digital world to the actuator. And a connectivity path across this network infrastructure with the unpredictable latency variation can put the operation of the application at risk. So in a nutshell, 6G needs to support end-to-end deterministic communication over heterogeneous communication infrastructure, including wired, wireless, cloud, and application domain. So this is a bit of a motivation. But when you see this, today's deterministic communication arena, you will see several communication technologies evolving. So we have TSN, DATNet, short form for time-sensitive networking, deterministic networking, and 5G, of course, as a complementary technology in deterministic communication network. These are basically essential technologies for network convergence to support all kinds of communication services within a same network infrastructure. And as you can see on the screen, they are evolving over the time and in different contexts. We had this first release of 3GPP. 3GPP supported interworking of 5G and TSN. But despite of this evolution of TSN, DATNet, and 5G, it is important to note that these standards originate from very different system domains. And TSN and DATNet are more originating from wired communication side, in which equipment and components are rather stable and predictable, has predictable performance characteristic compared to what we have as a characteristic in wireless communication. Therefore, very foundation of these standards are based on fundamentally different ways of capturing and expressing deterministic and stochastic characteristic. Furthermore, when we talk about end-to-end, integration of this technology is key to support deterministic communication services over a heterogeneous infrastructure and to support multiple application domains. So that brings me to a vision of Deterministic6G, as the name suggests. The main vision of the project is to set the foundation for future global communication standards for visionary use cases. And how we want to realize this vision? We want to do this by developing new concepts, features, and solutions to evolve the existing TSN and DATNet standards technology to become more wireless friendly, to become more adaptable. At the same time, we also want to bring new concepts to make 5G advanced, future 6G, to be better suited for deterministic communication. And together with this development, we also want to enhance application middleware framework. And here in our project, the focus is on OPC UA, which is widely adopted application middleware framework in industrial automation domain. So in nutshell, deterministic 6G will develop technical enablers needed to realize end-to-end deterministic communication services over integrated wired and wireless infrastructure. And these are the objectives. So the main objective of this project is to, as the call says, it's to develop new architecture that optimize deterministic communication. And as you can see on the screen, these are the three pillars of the deterministic 6G project. So first, we want to look into new architectures and protocols that ensures efficient and secure integration of 6G system in this deterministic communication context. Second pillar is focusing on 6G system awareness enabled by data-driven approaches. So today we have these model-based methods that these are considered as a workforce of cellular system design. I think most of you can agree on this. However, due to ever increasing system complexity, as we see in the recent standard, and also more and more observability and data being captured across the system, we want to leverage this by looking into new data-driven machine learning methods for determining probabilistic system guarantees. And the last pillar is on the anticipatory methods that leverages a digital twin of deployment scenarios and essential system dynamics. In other words, we want to create situational awareness by enabling interaction of digital twin of the 5G network, which is envisioned to optimize the operation of the network, future 5G advanced and 6G also, and the digital twin of the application domain. And this is what commonly referred is as digital twinning. On the screen, you see the key innovations. On the architecture side, we have end-to-end security. We have new concepts that goes towards ensuring that the edge cloud on the control plane and the data plane becomes more deterministic. Repeating again, evolving TSN and DetNet to become wireless friendly. And we have these three application area as focus. So first one is manufacturing, second is XR, third is wearable robotics. And our consortium basically is of 12 partners across Europe. So we have key industrial players in 6G research and development, including Ericsson, which is also a project coordinator. We have Orange, a big telecom operator from France, Montimaj and Kumukur. These are the SMEs from France and Finland. We have key industrial players as an application visionaries in the project. So we have BNR, which is a subsidiary of ABB, a very big player in industrial automation domain. We have School of Santa Ana and Evo, a startup coming out of School of Santa Ana, which focuses on this new innovative wearable robotics use case. We have KTH, specifically Professor James Gross is the technical manager of the project, which will, and then we have University of Stuttgart, which will take care of simulations and development of validation framework. We have, the project is running for 30 months. We have already started together with all other sister SNS projects. Yeah, that's about the consortium. And if I move on to the project overview, so we will start, as I said again, repeating again, the main objective is to develop end-to-end system architecture. And we started with looking into system aspects of deterministic communication. Specifically, we are right now looking into use cases that requires deterministic communication in these three application areas, as I mentioned before. And the natural next step is to deduce KPIs and KVIs. At the same time, what we are trying to do right now is to do security analysis, trying to understand what are the vulnerabilities when we talk about this, enabling this end-to-end deterministic communication for such use cases. And in the middle, you see this green box where all the key innovations are listed. So, these are the technology enablers, which will be integrated as functional blocks to make this whole architecture. And at the end, deterministic 6G will develop an advanced framework to validate this new proposed 6G concepts against this innovative use cases. And this validation framework will implement this new wireless-friendly enhancement on a system-level simulation tool and integrate them with the characteristic of wireless latency models. So this is the overall project overview. And if I move on, just wanted to give you a snapshot of what the use case areas. So these are the selected use cases. So first one is extended reality. So more on the immersive interaction side. We have this occupational exoskeleton use cases where you have this kind of exoskeleton that you can wear on the manufacturing shop floor. We have several use cases within this big application area of wireless industrial automation. And as I have said again, the plan is to basically trying to understand and then first investigate where exactly deterministic communication is required for such use cases. Yeah, and our plan from a dissemination perspective is to bring these technical enablers, this new concept towards standardization, especially enhancement in DETCOM standards. So when I say DETCOM, I'm referring to IEEE TSN, IETF DETNet, and OPC UA. And practically speaking, the target is to push these concepts towards this TSN working group, DETNet, relevant 3GPP, SA2, SA1 standard, depending upon the timeline that 3GPP will come. Basically, that will start from next year. And also that, if I repeat again, the plan is to basically feed the results towards OPC UA framework. Yeah. And also, we would like to contribute and let's say coordinate with our sister SNS project, trying to understand what they are doing and then trying to feed that back in this architecture that we are trying to develop. Yeah, and this slide basically gives you the whole overview of the project. And maybe given the time, I should skip this one. Yeah, and this is the summary. Yeah, and our website is alive. We have a LinkedIn page, Twitter page, and if you have any if you are interested to know more about this, you can always contact us at coordinator@deterministic6g.eu. I think I'm almost 20 seconds up.
You are done, Dhruvin? Yes.
Yes,
Okay.
I'm done. I'm sorry, I took 20 seconds more.
No problem. I think you were pretty much on time. So thanks a lot for the interesting presentation.